For this discussion, we have Alexander Ryerson, Mike Morgan, and Nicholas Genier. Mike and Nicholas are joining us from Tolko's High Level Sawmill, where they are the Harvest Operations Superintendent or Supervisor and Woodlands Operations Supervisor, respectively. Alexander Ryerson is a Forest Information Specialist at Limb Geomatics, which offers a turnkey GIS solution called OpTracker that Tolko High Level has been using for a few years. So they will be discussing Tolko's experience with this technology, which brings geospatial data and imagery into the cabs of operations equipment and provides tracking and performance analytics to managers in the office. So take it away, guys.
Thank you, Ellen. So as Ellen introduced, we're here to talk about how, my name is Alexander Ryerson, and we're here to talk about how Tolko Industries uses tracking and analytics to increase operational efficiencies. So just to begin an agenda, so we'll start with a welcome message for Mike, Nick, and I. I'll be driving the slide deck with Mike and Nick contributing throughout the presentation. We'll go through a Tolko Industries overview, Limb Geomatics company overview, and then we'll get into OpTracker with a high-level overview, and then Mike and Nick will discuss what it does for them in their operations. And then we'll finish off with a summary and a Q&A period. So as Ellen said, my name is Alexander Ryerson. I hold a Bachelor's of Science and Master's Science in Forestry and Master's of Science in Forestry. I've got about 10 years of boots on the ground operations experience before joining Limb Geomatics, where now I work closely with our customers to ensure that our solutions meet their needs. I'll pass this over to you, Mike.
Hi, my name is Michael Morgan. I am a Woodlands Operations Supervisor. I have a 2-year technical diploma from the Northern Alberta Institute of Technology, and I've been practicing forestry in Northwestern Alberta for about 25 years now. Over to you, Nick.
Nicholas Genier. I have forestry technician degree, 2 years from Sir Sanford Fleming in Ontario, where I began my forestry career and moved into Northwestern Alberta here in 2013. And I've been playing with the technology, so definitely operational background.
So Mike, I'll pass this over to you.
So what is Tolko? Tolko is a privately held company based in Vernon, British Columbia. We have operational divisions in British Columbia, Alberta, and Saskatchewan. And we have recently expanded our operations into the United States. Next slide, Xander. So we were founded in 1954 by Harold Thorlickson, who started in the Lavington Planer Mill. Since then, we've steadily grown as a company, purchasing sawmills and OSB mills. So Tolko came to High Level in 1999 when they purchased the old DMI mill, and we became Tolko High Level Lumber Division. So next slide. In 2008, we hit the big economic downturn that everyone remembers. Price of lumber dropped, and we started looking as a company at ways to operationalize and make our operations more efficient, because time is money, and we wanted to minimize the amount of time we were in the woods and maximize what we could get out of it. So in 2010, Brad Thorlickson assumed the role of president and CAO. And in 2011, we started our new strategic journey, which was Join the Journey. In 2017, we had been experimenting off and on with a variety of different metrics tracking systems and GIS systems, placing them into our operational feller bunchers, a little bit into our skidders. And in 2017, we came across a little company called Limb Geomatics who had a system called OpTracker. So we started looking into OpTracker and building and developing the system that we currently use today. it has been a great system, and we're going to let you know why. Next slide.
So I'll first lay out who is Limb Geomatics and kind of what we do. What's brought us here in front of you today with Tolko Industries. So we have a forestry geospatial platform. It's a suite of solutions from the left-hand side where you have LiDAR-based enhanced forest inventory, AFRIDS, which is a web-based decision support tool for harvest block planning using those EFI metrics. Prism, which is a data collection solution for boots on the ground, two-way synchronization for reporting in the office. And then what we're talking about here today, OpTracker at the top for that operations tracking and analytics. And then to the right, some other operational tracking solutions. And we're an Esri business partner, so we build custom solutions on the Esri platform. And in the middle, Stratus, which is the forest management data and analytics platform. So OpTracker, it's a web-based solution. Access the browser, access the web app through any modern browser on computers or tablets. It's built on ArcGIS Online, as you can see in the middle, which then you can take offline into the forest using iOS, Android, or Windows tablets. So it is agnostic of operating system on the tablets. It's also agnostic of machine type. And it connects with GNSS devices for that high precision accuracy. And kind of show the timeline to overlap with the one we showed for Tolko. So OpTracker was born in 2014 over discussions, getting drawn out on a dinner napkin up in Northern Ontario. Shortly after, Tolko started investing in OpTracker, using it, providing feedback for making sure that it had a good market fit. And now brings us to where we are now, which we'll cover in slides to come. So back to you, Mike.
So we were looking to solve ultimately two problems with the OpTracker system. First and foremost, we are a remote northern community with very limited access. So for us, spending a lot of dollars on layout programs, hanging ribbons in the bush was very time consuming and very expensive due to access and the number of people we were hiring. So OpTracker allows us to circumnavigate that by using GIS systems to replace those boots on the ground people by digitizing everything and then uploading it into a digital platform that the buncher operators can see right in front of them. And secondly, it allows the buncher operators to see a bigger picture of their productivity in their systems as to, what their uptime is and their operational productivity while they are actually harvesting the blocks. So next slide, I think is me as well.
Sure.
So the value that it brings to Tolko, 100%, it allows us to schedule the right machine in the right block to harvest the right wood. Our contractor force operates a large variety of different machines. So having the right piece of equipment in the right block, harvesting the right wood it makes our operation more efficiency, which lets our contractors monitor the operating efficiency of their equipment, monitoring their uptime, their downtime, maintenance time, and allowing them to replace machinery when it's worn out. It provides quick uploads and downloads of data into the operating system for easy and efficient data transfer. The older systems were very time consuming, with myself or any of the other harvesting supervisors having to visit each machine to update any of the digital data within the system. Now I can manage all of that from my desk in the office. It also provides us up-to-date tracking of boundaries, watercourses, and roads during active harvesting operations. Because it is a web-based system, we are able to go online and monitor our equipment and see where they're actively harvesting and if they're close to boundaries, if there are any road changes, or if there are any boundary additions. And finally, it streamlines our data management for large quantities of base operations data so we can leverage our existing GIS investments. We invest a lot of money in our GIS systems, managing our data, and it helps, OpTracker helps us to make it quick and easy to flow the data from the field into the office and off my desk.
So it does allow for a great two-way synchronization. So as Mike said, it gets it off his desk and gets it to the machines. So the guys, you do need cell service. They're able to upload new maps. They're able to push their tracks to the office, which allows Mike to create the as-built, see if he has any concerns, and then allows him to communicate with particular harvesting supervisors to go and check on any errant data. So GPS spikes, which happen, things like that, and just making sure that we're keeping where we're supposed to be within the blocks. Connecting to that external GPS is great, right? We have to do, we do ribbonless harvesting here in high level. And this allows us to do that with that sub-meter precision right in the machine, and away we go. So we pair it with an arrow currently. The boundary proximity alarms are great. So the operators, the screen flashes, it makes an alarm, and they know they're approaching, be it a water course, a cultural buffer, or any other value that we've indicated needs protecting in the woods at the layout phase. So rather than having to go and hang ribbons around it, we've digitized these boundaries. We've added a little buffer, and then these proximity alarms warn the operator. And then they're taking that extra caution, making sure they're zooming in on the screen and seeing where they are in the woods and cutting appropriately. The measuring tools within the system are quite great and robust. It allows the guys to create things like split lines if there's more than one machine within a block. So their distance to roading and allowing for that second phase of skidding to come behind the bunchers. As well, it also allows them to measure area, not just distances. So if there's fringe wood that was missed at the layout phase and the planning stages, we do have a tolerance and are able to make additions. So they're able to measure, give an estimation of what they think is there, report to their supervisor prior to cutting, and then we can look at it, say, yep, it's within the tolerance, ground check it, and then have them go in there. But we know before we get to the field what we're looking at. The georeference notes in the field. So an operator comes across something, be it a nest, some of this layout's 2 years old, right? So be it a nest, be it a water course that was somehow missed, they're able to take a note in the field, and then when they sync, Mike's able to see that stuff, and again, send the appropriate ground troops, we'll call them, to the field. So it's that two-way communication, as well as downtime codes. The auto setup toolbox is important. So when this first started, there was a lot of maps and creating. Now it creates a lot of maps in a quick amount of time because of that automatic setup. And then the user permissions configuration. This allows us to keep operators out of certain pieces of the software that they're using. So things like turning off and on the proximity alarm, the distance from it, turning on the tracking intervals, things like that. This makes sure that they're kept out of those configuration pieces, and we're able to move on with that. So it keeps it locked down.
As you can see, we've progressed from the early stages on the far left of just having a map showing where the block was, to now we can add imagery to it, topography, having all of our protection layers, and allowing our operators to make quick decisions in the field while they are operating, which helps to increase their efficiency and make them more productive, which is the ultimate goal of our investment in this system, is to make our contractors more productive, which makes them more money, which makes us more money, and we all like money. So next slide. So the heads up display is the screenshot you can see. It does allow for an easy transfer of data from the operator to the home base system, and then from the home base system back to the operator. It's all through Wi-Fi. It's super efficient. It integrates very well with the Esri ArcGIS platform. We predominantly use the ArcGIS platform, and the integration between the two systems has made it very quick and efficient for us to manage that data quickly and be able to respond and adapt quickly to changes within the forest. It allows the operators, to see their operational progress. Where have they been? Where are they going? What are they coming up to? They can see their roads. They can see their buffers. All of those important things that, again, help to improve the operational efficiency in the field. The boundary alarms let them know when they're getting too close to something, which has absolutely cut down on our environmental trespasses in the field. It also allows us to mark and label sensitive areas and then prevent them from entering those sensitive areas and doing any impact to them. And of course, as Nicholas said, we do ribbonless harvesting, which allows us to save money by not having a large mass of people out there hanging ribbons in the bush, and making mistakes, making decisions that we may have to go back and fix at a later date.
So these georeference notes within the field, again, it increases that collaboration, that communication. It allows operators to have that sense of input. It also allows, so there's the georeference notes, but it also allows downtime tracking. So there's some of that stuff. That communication between the two systems. And then because it is that online piece, Mike is able to see these notes and apply the applicable buffers, send somebody to ground truth it, and we're able to move on quickly and efficiently as soon as we have that data and we're able to check, right? So this just allows for that quick and easy collaboration. Next slide. So operator efficiency is a priority. So having the imagery and being able to see that, there are other layers we've been able to add in the past, such as bare earth imagery, which allows them to see their topography in certain areas. High levels relatively flat, but there are areas where that makes tracking some of that stuff even more important. Operators are in control in how they view their tracks. So just their color displays and stuff like that. Once it's synced, the different machines are different colors so they can see where they've been. And if there's more than one machine in a block, once they've all synced, they're seeing each other's tracks so they can see who's done what pieces. The auto tracking for off operations. So as soon as they're within the block boundary, it begins taking those track logs and those lines, which is quite nice. If they're going outside of that boundary, they're able to manually override, and it continues to track and gain that information as we go. It allows them to see where they're going, and having that heads up is key, right? Next slide. So the measuring tools in the field. This one is huge, being able to draw those polygons, look at those additions, as well as being able to figure out split lines, retention. So if retention needs to be moved for some reason, due to operational needs for change of a road, to increase skidding functionality, to increase skidding efficiencies, or there's some other reason to move that, they're able to measure a patch of equal size and move it within the block to maintain our retention goals. And the measuring distance is keys to being able to making sure they're not increasing their skidding distances, creating those split lines, and they're able to draw on the map so that they're able to see it. And then again, once they sync, those polygons are coming across to everyone. So it's all pretty handy stuff. Next slide.
So the web application innovation. The automatic analytics are calculated nightly after the unit is synced and uploaded into the system. It processes the progress of the block and the productivity of each machine. It lets us know if the machine was stopped, why was it stopped, and how far they've progressed throughout the day. There are patch downloads for analytical files where we pull all of our data for tracking and updating the current harvest operation within a block or within a harvest area. So we know where we're going and we can quickly adapt to changes in required volumes based on our progress on a daily basis. It prepares operational units from existing business GIS layers. It integrates with our already existing GIS system, so it's a quick and easy transfer of data. And we can add any ancillary layers from a feature service URL, which means I can pull any additional data that our operator would like to see on the heads-up display and quickly add it to the system daily. Next slide, Xander. So the application uses, again, it allows us to track the actual productivity of the machinery. It allows us to see daily where we are harvesting and where all of our different machines are located. We operate about five different contractors throughout 3 million hectares of our FMA, and they're on a daily basis. There can be anywhere up to 40 different feller punchers operating in the area, and we can pinpoint in on those machines and see where each machine is operating and what their productivity is and where they're going. Next slide. Again, it integrates with our existing ArcGIS platform, and we can quickly add and remove any ancillary layers directly in the app. We can just flick them on, flick them off. If we do not want to have our DIDS layer on it because it's muddying the waters of what's going on, you can just turn it off and add it again later at a later date. It allows us to manage all of the data collected in one place on the web app. We can add the imagery in the background. So rather than just staring at a white background, they're seeing the topographical layer, the actual orthophoto layers, which allow them to see upcoming streams, what the boundaries of their blocks actually look like. And it allows us to prepare operational units using existing business layers. So we already have the layers set up and constructed as a company, and this allows us to just pull them out of our existing GIS system and push them right over into the op tracker system. So the progress and productivity analytics. We can view progress and productivity with the automatic analytics. The op tracker system will process the analytics on a nightly basis. So when you wake up in the morning, you can pull it up and you can see how productive everybody was, and you can manage your equipment fleet to know if you need to add more punching power, if you need to add more skidding power based on those productivity metrics. Again, we can import and export data in bulk for other solutions. Specifically, we use it to provide the regulating body here with an up-to-date as-built at the end of our system or at the end of our operating season, rather than waiting a year to fly imagery and then digitizing that imagery. We can provide them that as-built layer significantly faster than we have previously. and it allows us to configure sensor thresholds for various operating conditionals. The different sizes of machines obviously operate at a different speed, and they cut different sizes of wood, and this allows us to specifically configure the operating system so that we get that right piece of equipment into the right block, cutting the right piece of wood. Next slide.
So the operator specific hours on sites, the total times, active time and productive times, this is where it all comes together and you're able to report. This is also where the contractors are gaining a great benefit. So they've been able to see their progress as the sawmill and as the customer are able to see all of that. We're reporting that to the regulating body, but the contractor being able to see it really ties it all together. They're able to look at this, they're able to, and because they're able to see it by machine, see their uptime, their downtime stats, they're able to schedule things like maintenance, they're able to schedule things like operators into specific blocks, right? Like we talked about, you get that larger piece size, the machine slows down. Well, this is able to link it back to the block, and they're able to track which operators are doing better in what wood chance. So you're able to schedule your guys and move them around a bit. It's tracking your areas covered per shift. So again, you're able to see that productivity by machine, by timeline. So you're able to see and link it back to an operator and link it back to your overall fleet health in regards to that. It's easy to use. It pulls it out in a CSV and it goes really well for this. So this is really where it ties back together and how we've managed to get it so integral to our system is that we've gotten that contractor buy-in through these easy to use reports and easy to see pieces. So they're able to see where their machines are on the ground. They're able to see real-time data or nearly real-time data on the back end of what the machines are actually doing out there on the ground. They've got, right? So it really helps the contractor out as well as us. And that's really what ties it all together and makes the system work. Next slide.
I think this is me now.
Yeah.
All right, thanks guys. So I really appreciate working closely with Nick and Mike. We're constantly brainstorming new ideas. Even today, we just been chatting, came up with another few ideas this morning. And that really speaks accolades to the relationships we build with our customers to ensure that our products are evolving to meet the needs for people like Nick, Mike, and their contractors, and as well to adapt to that evolving technology. We also had a screen grab that we snuck into here that shows that we're in active development on FP.2 integration. And I'd also like to invite everybody to connect with us to join Dr. Kevin Lim's podcast, The Digital Forester, which is launching next week. As well, another link here for a case study that Mike worked on with EOS and Esri, as well as OpTracker, just to demonstrate additional value that Tolgo realizes with these solutions and being innovative in the forest industry. So I'll stop here. I'll open up the floor. We just wanted to leave our contact information for everyone. If you don't have time for a question today, please connect with either one of us. So thanks, Ellen. I'll pass this back to you.
All right, thanks guys. That was a really interesting presentation and good to see how this technology has been working for Tolko. We've got a lot of questions here, so we'll just try to get to as many as we can. First off question, I would think this is for Mike and Nick. How are you accounting for boom offset while using sub-meter accuracy GPS, and are you accounting for machine heading? So
for boom variance, we actually created a halo around the machine, which is a 7 meter, which accounts for that boom reach. It's also within our standard operating procedures that when they're cutting boundary, they're to keep door side to that boundary and swing to the right. So we do realize a slight loss in productivity there. Not so much, we're just not making quite as wide a pass on that first cut. And that's how they've integrated with that. in regards to heading, the only thing that's used there is just the track log and the fact that the line's behind you. And it's following you. It's an Esri-based program, so it's following you real time line, and it's not just a dot every 10, 15, 20 meters, right?
Okay, great. So another question, when there is no cell service, is the operator required to transfer a tablet back to camp for data upload and sync, or does each operator have their own tablet if that's the case?
So with double shift machinery, you do need cell service. So if you're not within cell service, you do have to transport it back to camp. So we've often gone to every or a weekly download. Many of our contractors run single shift. They've just got more iron out there and they're running single shift. So in that case, operators are bringing the iPad back to camp daily.
Okay. We have a question asking roughly how many trespasses occur within your operations in terms of boundaries.
You want me to take that one?
You can take that one, Mike.
Initially, when we started looking into these systems to begin with, we were seeing on average probably 10 trespasses a year. And since we've integrated the op tracker system into our operation, we are probably down to 1, maybe 2 a year, which for us is a fairly significant drop. And it has definitely reduced the number of trespasses we had, and it's also helped to increase the trust between ourselves and our regulator in the province that allows us to operate this way.
To put that into perspective quickly, just those numbers, we cover about 8,900 hectares, and we log from November to the end of March. So everything's happening quickly. So that, just to put that number into perspective.
Yeah, that's awesome. I think we have time for one last question here. Is there any additional technology required to complete the download and upload of data and transfer that data?
A Wi-Fi connection.
Okay.
So yeah, for the connectivity piece, it's the iPad that the guy's using anyway. And then just making sure that it has Wi-Fi data service, some connection there. So it's literally an iPad and a GPS system. If you've got ribbon and things, you don't even need that GPS piece.
We are currently working with LIMS Geomatics to integrate the FPDAT2 system, working with the op tracker system, which will gain us a satellite upload download system, which will eliminate the need for that Wi-Fi connection, which will then allow us to do this we'll get 30-minute uploads of, I guess we'll get the data uploaded into the system every 30 minutes.
Okay, I just want to sneak one more question in there because I think this is a good one. Was it easy to get contractors on board and sort of allow op tracker to be installed on their machines?
So I'll take this one as the lead with that. It was relatively easy once we were able to prove out the gains. So we're very open with our contractors and we had those conversations. We are required to collect that GPS data anyway. So we've always had a GPS of some sort in it. So we went from having tablets with an Esri-based offline system that we were uploading shape files into, running around with USB sticks, collecting track logs. Then we went to FPDATs for a while, which again were USB sticks having to download the track logs and upload maps to this system, which they can control. It's one source of data that Mike is able to update. So, and through this whole progress, as we've changed from system to system, we've kept them on board. We've had lots of meetings with them. We've shown data. We've allowed them access to their own data. So they're leveraging that data as well. So it's benefiting both sides, and it's not just about the mill's benefits. And they're able to leverage that data as well. So that's how we got that buy-in is we're providing the service, we're footing that bill, and they're also reaping benefit to us collecting that data.
Okay, awesome. Unfortunately, I think we're out of time for questions, but if we didn't get to yours, feel free to email the speakers, or the speakers, I'll let them know the questions that we didn't get to. So thanks again, Alexander, Mike, and Nick, for your presentation.